Hello, and welcome to Invitation to Puzzles, where today I have for you something quite unusual, which is a pill arrow puzzle. So you may have seen arrows before, like this one, where the digit in the circle is the sum of the digits along the arrow. So 2 plus 3 plus 4 is 9. But the sad thing about arrows, you might say to yourself, is you can't make an arrow that sums to a double digit number. But in fact, you can if you use one of these. So in fact, one of these pill arrows, that's actually saying the sum of these digits is 23. So you could do something like 689 is 23 for this particular arrow. Do remember that the sums for arrows, and this is equally true for pill arrows, count separately. So these 3 sum to this total, and these 5 also sum to that total. Okay. Digits are allowed to repeat as long as Sudoku allows it. So keep that in mind. But with that, I'm going to let you give the puzzle a go. There's a link down in the description below. But let's give it a go ourselves. So one of the things that happens a lot in pill arrow puzzles is that the first digit is usually quite restricted because the first digit here is the first digit of the sum of these 3. So what's the largest it could possibly be? Well, if these were 7, 8, 9, this could be 24. So this first digit can only possibly be 1 or 2. If I try and make this like a 3, I'm saying I've made these digits sum to 30 somehow, which means on average they're more than 10. That doesn't work out super well. Same deal here, and indeed here, because these are each a sum of 3 digits, so it's most 7, 8, 9, which is 24. So this digit, though, now sees a 1, 2 pair in its column. So this digit's at least a 3. But what is it at most? If this were 9, 8, 7, 6, 5, that's 35. So this digit's at most a 3. And I'm going to go ahead and fill in. It's at most a 3, and this digit, we said, can't be higher than 5, just for the sake of it. Okay. What else can we do? Let's see. This is a sum of 5, so certainly that's 1, 2, or 3 as well. There, I don't think I know which one it is. In fact, actually, if I look at the minimum sum of this one, the minimum sum is 4, 5, 6, 7. And if you do 4, 5, 6, 7, that is 22 already. That's because there's a 1, 2 pair in the column. So this already sums to a 20-something number at minimum. So that's always a 2. That's the 1 over there. Okay, so 20-something number doesn't have that many options. 21, 23, or 24. I'm realizing I can't possibly put a 1 on this arrow anymore. That's owing to the fact that if I try and put a 1 on this arrow, oh, I see. Sorry. You'd think I'd remember this from a puzzle I made, but alas. This is an advantage of the fact that I seem to have no long-term memory, is that I'm like, oh, that's what I meant. Okay, so was going to say there's no 1 on this, but I'm going to do you better. This digit's big because the sum of these 3 digits is at a minimum 1, 2, 3, which would be 6. So that actually means when I maximized this before, I said it's maximum 5, 6, 7, 8, 9. Well, it's not maximum 5, 6, 7, 8, 9. It's maximum 4, 5, 7, 8, 9. And that's because I can't use all of 6, 7, 8, and 9 in this row. I need one of them there. And this totals actually only 33. Now, I can't make this arrow sum to 33. So what you see is I, in fact, have to make it sum to 32. There's no other choice. And now I can use my whole trick about the whole row summing to 45. If you've not seen this before, every row, column, and box contains the digits 1 through 9. And so if you once do the calculation, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, you'll find that that's 45. And that's helpful because you know these sum to 32. Those two sum to 5, so that's 37. That means these two sum to 8. And the only acceptable combination, given that I can't use 2, 6, or 3, 5, is 1, 7, and they have to go in that order. Okay, that makes that a 2. 7 and 3 is forced. It has to be 1, 2, 4. Okay, and the 1 isn't up here because of that one, so that's always a 1. If we look back over that. We now actually know what this digit is, because remember we said the maximum this could sum to is 24. If these are 7, 8, and 9, that would make this 24. Well, that digit can't be a 4. So it's got to be a 1, 2, or 3, but 1 and 2 are gone. So this has to be 23. Exactly. And if this is 23, there's only one way to accomplish that. Because remember, 7, 8, 9 was the maximum. The only way I can make it 1 less is to replace the 7 with a 6. Anything else, I will reduce the total by too much. So the 23 and 3, it has to be 6, 8, 9. Okay. Which has a sort of weirdo sideways impact on this digit. Because this digit can't be a 3 anymore. Because if this digit was a 3... then these would also be 6, 8, 9, but that would make 4 6, 8, 9s in box 5. And 4 6, 8, 9s is too many 6, 8, 9s. So this can't be 23. It has to be 24, which means that these are 7, 8, 9. And if we take a second to admire this beautiful quadruple that has appeared before our very eyes, we notice the 7 in the 6, 7, 8, 9 quadruple is up here, and the 6 is down here. So this isn't a 6, and that's not a 7. Okay, so that is helpful. We know there's a 7 down here somewhere. We know there's an 8, 9 down here. In fact, what's left in this row? If I look at what's left in this row, one of the things left in this row is a 3, and it can only go there. And then these are just a pair of 5, and it looks like 6. And if I do the same thing in this row, one of the digits that's missing is 4, and it can only go there. And then these are a triple of 1, 2, 3, 4, 5, 6, 7. So they're 1, 5, and 7. That one's definitely not the 1. Okay, so we got some additional Sudoku happening, and this is a triple now of something, something, and something. 1, 2, and 5. That one's not a 5. Okay. Oh, and I guess we know that... oh, we almost know a triple for these. But it's worth writing down just so we can look at this sum. What is over here? So we still have to place the 7, the 8, and the 9 in the box, along with the 4. And we know for sure this isn't the 4 or the 7. So this is, funnily enough, an 8 or a 9. It's an 8-9 pair in the box. These are the 4-7 pair, actually. So those sum to, well, a minimum of 19, actually. So 4 plus 7 plus 8 is 19. That means these two cells sum to an absolute maximum of 4. Well, that means neither of them is 5. In fact, actually, this one also is a maximum of 3. So it's got to be 1, 2, right? It can't be 3 because of the 3 in the box. And now we can actually sort of fill this in because these two sum to 11 plus 3 is 14. We need 9 more to get to 23. So that's actually the 9. That's the 8 over there. So these are a 6, 9. That makes that the 9 up there. We can place the 9 in box 1 now because we've got 2 9s looking up at box 1. So the 9 actually goes there. What's the smallest these can be, I guess, now? Because now this is minimum 945, which is already 18. So it has to be that because this can't sum to 19 anymore. So this is 945, and we even know the order thanks to that 4, summing to 18. No 5 there. Let's see, we'll get the 2 and the 4 up there. These two, 2, 3, 4, 5, these are 6 and 7, and we know the order on that as well. So that's not a 7. These two need to sum to 11. They're not 4, 7, or 3, 8. So these are 2, 9, or 5, 6. I don't know which. I'll just leave it like that. Can do math in this column, though. So we can repeat the trick with the 45. These digits we know sum to 24, 34, 37, 39. All of that together tells me that this digit is a 6 in order to make that column's math work out correctly, because I need these to sum to, again, 24. That's actually going to place the 6 in this box. Oh, by the way, this 1, 2 pair made this a 5. I didn't ever notice. This digit isn't... right. Neither of these is 5 because of the combination of those two 5s, which means this isn't 5, 6, it is 2, 9. I was trying to figure out why that one couldn't be 5, but it was the given 5 hiding from me, as given digits are always wont to do. So these are 2, 9. Let's see. Can we do anything with this box? We only have 2 digits left in the box, one of which is a 3, so it goes there. One of them is an 8, which goes there. Let's see, these are a 4, 5, 7. We know that one's not a 5 for whatever that is worth. Doesn't feel like it's worth a lot, if I'm being completely honest with you. And of course, I'd always be honest with you, dear viewer. I'm going to fill in these 2 rows. It might prove gratuitous. 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this isn't 4 or 5. That's not 5. That's not 4, 8. These are 3, 4, 5, 6, and not 7, 8, or 9. Okay. In this column, this is only a 1, 3, or a 7. However, one of these by Sudoku has to be a... Well, sorry, not by Sudoku. One of these has to be a 1, because if neither of them is a 1, this arrow sums to 37. And 37 is too big, because remember we sort of maxed out earlier the sum of 5 digits is 98765 is 35. So if neither of these is a 1, they just are 37. So that doesn't work. So in fact, one of them is a 1, which means that one's definitely a 7. which then makes that a 5 and a 1. Okay, now we have to decide, does this arrow sum to 13 or does it sum to 31? And it can't sum to 13 because the minimum sum of these 5 digits, 1, 2, 3, 4, 5, is already 15. So it's more than 13. So instead, this arrow has to sum to 31. Okay. So that seems big. Let's see if we can do a little Sudoku around this arrow so that we can do our sum of the row trick again. Okay, so we've got 1, 2, 3, 4. We still need a 5 and a 6. We've got the 7. We need an 8. And we've got the 9. Okay, so this is 5, 6, or 8. Okay, let's add these up. So this is 31, 32 in total. That means these need to add to 13. And the absolute minimum sum of these two is 5 plus 4, which is 9. Which says that this can be, sorry, I said 13, right? Yeah, 13. So this can be only a 3 or a 4 because I need to make sure the math works out. And this can't be 1 or 2 by Sudoku. But now if I look over, these two now sum to a minimum of 8. And therefore, this can't be a 7 because that would be 15. So that's a 4 and that's a 7, which now means this is a 3. And now we remember that the total sum needed to be 13. So that's a 6. Okay, so we can get rid of, oops, or we can draw lines. Drawing lines is always fun. I like line drawing puzzles. 8 and 5 go in. And so now hopefully we have some more Sudoku that is going to bless us with its appearance. I see that I can place a 5 here by the 5s looking into the box. These are 2 and the other thing. 2 and 8. So that is the 2 and that's the 8. And that 2 sees across, oops, sees across here, making that a 1, 2, 1. That seems to place the 1 in this box there. Let's see. Do we have other weak points that I should be pressing on immediately? Where do 1 and 2 go in box 9 is what I see. So let's do 1 first. 1 in box 9 is there, and that's the last one in the puzzle. Now, where does 2 go in box 9? Now it goes there. I was going to do it as a hidden pair, but that was overly fancy. I just needed to place the 1 and then place the 2. So these are 4, 5, 6, 7, 8, and 9, and we know those aren't 7, so that is. So that sorts out those 2, which sorts out those 2. Those are a 5, 6 pair, so this is a right-in. It is an 8. Let's see. Let's see, that's a right-in. 2, 3, 4, 5. It's a 6. See, this triple, 2, 3, 4, 5, 6. These are just 7, 8, and 9. Funnily enough, oops, not 0. Let's see, that is a 7, 8, 9 triple in column 4. Making that a 2 and a 9. Oh, Lord. I made this so much more complicated than I needed to make it. This has been a 2-9 pair sitting in this box the whole time. And I didn't rule 9 out of those. If I just ruled 9 out of these, then I would have known ages ago that this was a 5 and everything would have collapsed. I felt like this was being a little bit grittier than I was expecting. It's just because I wasn't paying attention. Okay, yeah, so that probably makes us able to finish the puzzle. Okay, that's a 3. Yeah, that just goes to show you, you're not always going to find the nicest thing. There can be a nice thing, but that doesn't mean you're going to find it. That's a 4. It's a 7. and a 3. Oh, sorry, I said that like it was going to be the end, but now it's the end. This is a 6. There we go. Alrighty, thank you for joining us for Invitation to Puzzles. I hope you enjoyed that. If you learned something, let me know in the comments down below, and I'll see you next time on Invitation to Puzzles.